All right, guys, remember, this whole unit is all about solving equations and inequalities, any type. And so the one we're going to do right now is the absolute value equations. But first, I want to refresh your memory on what absolute value is. Remember, absolute value is the distance from zero on a number line. So if you're looking at the number line, and here's -5 and 5, the distance between -5 and 0 is 5, and the distance between 0 and 5 is 5. Distance is always positive. So we remember that from Unit 1, that distance is always positive, absolute value is always positive. So when we solve equations, we're going to go back and fill in the notes, but first I want to talk to you about it. I can look at number 1 and I can use common sense, and I know what my values of x can be. If I know that it's got to equal +2, my x value can equal 2 because the absolute value of 2 is 2, or my x value can equal -2 because the absolute value of -2 is 2. Does everybody see how I'm evaluating x and I'm getting 2 for both of those? And then, because there's more than one solution, absolute value is going to have 2 solutions. So because there's more than one, we have to write it in algebra as a solution set. So we write it as x equals a bracket -2 to 2. Here's where I want you to pay attention and highlight. It's very specific. So a lot of students will say, well, I don't know how to do a bracket. Can I just do a squiggly? No, you can't. If you don't know how to do a bracket, I want you to practice. So when you practice making the bracket, just think a sideways U, an arrow, and a sideways U. A sideways U, an arrow, and a sideways U. You have to do it because that is how it is read in all of algebra, pre-cal, algebra 2, and so on. So you've got to get used to that bracket. Notice inside it's least to greatest. So if you tell me 2, -2, you will get points off. So for the full points, I need a bracket, least to greatest. That's number 1. Now, let's look at number 3. And again, I can use a little bit of common sense. What does my value of z need to be for me to get a +40? Well, I know that 8 times 5 is 40, so z can be 8. And I know that -8 times 5 is a -40, and the absolute value of -40 is 40, so z can be -8. So again, more than one solution, so I'm going to write as a solution set, least to greatest. Okay? All right, now, let's take a look at number 5. Here I have d plus 1. So it's going to be equal to 8, the absolute value. So I know 7 is going to fit this criteria. 7 plus 1, the absolute value of 8 is 8. A lot of times students just say, oh, I found 7, let's just make it -7, because that's what happened in number 1 and number 3. Well, if I plug in a -7 here, a -7 plus 1 is a -6, and the absolute value of -6 is not 8. So -7 is not going to be okay here. So now we need to do some thinking. What number plus 1 would give me the absolute value of -8 in order for me to get 8? Think about it. Do you know? -9. -9 plus 1 gives me -8, and the absolute value of -8 is 8. So d equals -9. Again, it's a solution set, so d equals -9, 7 in bracket. Okay? Now, let's look at number 7. What? How would I even start? I don't know. So remember, in math, we want to be efficient and we want to be correct. So now there's going to be steps to follow in order to get my solution set for absolute value. I know I could set this equal to 34 and find out that this value of n needs to be 8 because 32 plus 4 is 34. But how would I get my other value? So that's when we are going to start and look at the steps to solve. So go back up in your notes. And remember, when you're stuck on homework, when you're stuck on examples, I want you looking at these steps. We don't just put them up there for you to ignore them. I really want you using them. So, step 1 is to make sure the absolute value expression is isolated. That's that fill in the blank. Make sure it's isolated. Well, what does that even mean? What does isolated mean? Let's take a look at what isolated means. Having the absolute value brackets isolated means it's by itself on one side of the equation. So if you look at number 1, it's isolated. It's by itself. Constant term is on the other side. Number 3, absolute value is isolated. 40, the constant term is on the other side. We're isolated. Number 5, even though it's a binomial, my absolute value brackets, D plus 1, are isolated and 8's on the other side. Number 7, it is still isolated. This absolute value bracket is still by itself and 34 is on the other side. Number 9, not isolated. Here I have the absolute value of C, but I've got this constant term, this plus 2 going on, making it not isolated. Number 11, I've got this 6 here. It's not isolated. Number 13, I've got this dividing by 6, not isolated. And number 15, I've got this 7 and negative 6, not isolated. So that's what step 1 means. Step 1 is saying make sure that the absolute value bracket is isolated. Step 2 says set the inside of that absolute value bracket equal to the positive value on the other side and set the inside equal to the negative value on the other side. So if you'll notice in step 2, that means I'm going to be solving 2 separate equations. I'm going to start branching it into 2 groups. 1, make sure it's isolated. Step 2, divide into 2 equations. Step 3 is going to be solve both equations. And step 4 is we're going to write our answer as a solution set, which those brackets. Okay, so let's talk about what that means. We already did 1, 3, and 5. Let's look at number 7. So is it isolated? Yes, my absolute value is isolated. Step 2 says break it into 2 separate equations. The first one, I'm setting this inside 4n plus 2 equal to the positive value on the other side, which is 34. And I'm setting this inside 4n plus 2 equal to the negative value on the other side. Why am I doing that? Because remember, this inside can equal negative 34 because at the end, I'm going to evaluate that negative 34, the absolute value of negative 34, and that's going to give me a positive 34. So that's why I'm setting it equal to the positive and negative values. Once I have my 2 equations set up, I've branched them, they're set up, now I'm going to solve it. Minus 2, 4n equals 32, divide by 4, and n equals 8. Subtract 2, 4n equals negative 36, divide by 4, n equals negative 9. And now I'm going to set step 3 is a solution set, or step 4 is a solution set, least to greatest. And then I box my answer. Of course, what makes algebra great at this step is that you can check your answer. So if you plugged in a negative 9, that would be negative 36 plus 2 is a negative 34. And the absolute value of negative 34 is 34. So negative 9 checks out. I can also plug in 8. 8 times 4 is 32. 32 plus 32 is 34. And the absolute value of 34 is 34. That checks out. Okay, so let's look at some examples. Let's do one more here, and then we'll go into some other ones. So step 1, isolate. It's isolated. Step 2, I break it into 2 groups. I set the inside, negative 2v minus 5, equal to the positive value, and I set the inside equal to the negative value. Notice, did I change any of that inside information? I didn't. Do not change that inside information. Keep it the same. And now I'm going to add 5. Negative 2v equals 22. V equals negative 11. Add 5. Negative 2v equals negative 12. V then equals positive 6. I set as a solution set, least to greatest. And of course, I can check my answer. Negative 11 and negative 2 is positive 22. 22 minus 5 is 17. That checks out. Look at, if I plug in 6 here, I get negative 12 minus 5, which is negative 17, and the absolute value of negative 17 is 17. That checks out. Okay, so now let's take a look if it is not isolated. So let's answer this question real quick. What if there is stuff outside the absolute value bracket? Here's what we do. We isolate. We need to isolate first. That's my step 1. So if I look at number 9, I've got to get rid of this positive 2, so I subtract it. And now I have absolute value of C equals 10. That's step 1. And now I branch it into 2 groups. I set the inside equal to the positive value. I set the inside equal to the negative value. And there's nothing for me to solve because C equals. And then I set it in bracket form, least to greatest. And then, of course, you can check your answer. Absolute value of negative 10 is 10. 10 plus 2 is 12. Absolute value of 10 is 10 plus 2 is 12. So that checks out. Let's take a look at number 11. It's not isolated. So step 1 is to isolate. Well, this is being multiplied together. So the opposite of multiplying is dividing. So I'm going to divide 6 to get my absolute value isolated by itself, and that equals 4. And now I branch into 2 groups. Set the inside equal to the positive value, set the inside equal to the negative value, and make it a bracket. And then, of course, I can check my answer. Absolute value of negative 4 is 4. 4 times 6 is 24. Absolute value of 4 is 4. 4 times 6 is 24. So it checks out. All right, number 13. Remember how I get rid of this dividing by 6. What's the opposite of dividing by 6? Multiplicative inverse. We flip it. So I'm going to multiply both sides by 6 over 1, or just 6. And then I get absolute value of 2w minus 4 equals 18. Now it's isolated. Step 2, branch into 2. Set the inside equal to the positive value of 18. Set the inside equal to the negative value of 18. And solve. And you guys are masters at solving, so I'm just kind of working through that so you can see. And then add 4. 2w equals negative 14, w equals negative 7, and then again I set it as a solution set and box my answer, and I can always check it. Negative 7 times 2 is negative 14, negative 14 minus 4 is a negative 18, absolute value of negative 18 is 18, divided by 6 is 3. Plug in 11 for w, 2 times 11 is 22, 22 minus 4 is 18, absolute value of 18 is 18, divided by 6 is 3. So that also checks out. Now, look at number 15. You got lots of stuff going on. So when you're isolating, this is still like a variable. Even though it's 2 terms inside that absolute value bracket, this is still a variable that we are trying to isolate. So imagine if I placed an x inside here. What would I have to get rid of first? I want to get rid of my constant term first. So I would do additive inverse by adding 6 up here. It's the same thing down here. I'm trying to isolate this, and it's attached to my coefficient of 7. So the first thing I want to get rid of is this negative 6, and I do that by additive inverse. Add 6 on both sides. And I'm left with this. And now I'm going to divide both sides by 7. And I get absolute value of 4n plus 8 equals 7 goes into 11 one time with 4 left over. 7 goes into 42 6 times. Now it's isolated. So now that it's isolated, I branch. So I get 4n plus 8 equals 16. 4n plus 8 equals negative 16. And then solve. So I'm going to solve this real quick. 4n equals 8. N equals 2. Subtract 8. 4n equals negative 24, n equals negative 6, and then I do as a solution set, negative 6, 2. And then, of course, I can check my answer. So that's the rundown of how to do it. So step 1, hopefully that makes sense now, and if you get lost, go back and look at your notes. But step 1, isolate. Step 2, branch. 3, solve. 4, put in a solution set. Okay, now, here is a special case. Remember what absolute value means. Absolute value means it's the distance from 0 on a number line. So can distance ever be negative? No, it can't. So you will see one of these on a quiz. You will see one of these on a test. Is this a true statement? Can any value of x in here with the absolute value ever be negative? No. No solution. No solution. So watch for that. Now, sometimes it looks like it's going to be positive. But you have to ask yourself, is your absolute value isolated? It's not isolated. So you can't determine if it's no solution until you isolate. That's why step one is always important. Isolate that absolute value. So if I divide both sides by a -3, I get the absolute value of 2x plus 1 equals a -7. Can I have the absolute value equal to a negative? No. No solution. So be careful there. That's going to be tricky. So watch out for that. If your absolute value is isolated, it can't be a negative. If you get lost on this, come see me for tutoring. Good luck.